Hello and welcome to today's class. Here we have to solve for the value of a in this challenge. The question is 2 to the power of a equal to 15. This is a simple exponential challenge here. Okay, but there's a reason for every video, and the reason will soon be unveiled to you. Yeah, look at the question. Can we write 15 in base 2? No, but we can simplify 15 into its prime factors. Okay, so let's take a solution first. So we have here solution. All right. So the question is 2 to the power of a equal to 15 here. Now, like I said, 2 here is the smallest base here. We can express this figure. And here we cannot express 15 in base 2. But we can simplify 15 down into its prime factors. How? Let's take 15. So you have here 15. What can go into 15 is 3. So 3 to 15 will give us 5. What can go into 5 again is 5. So 5 into 5 will give us 1. So we can rewrite 15 as our 3 times 5. So we go ahead and rewrite 15 as 3 times our 5. So what's the next thing we do? We can easily put this in bracket. So the next thing we do here is easy. Here we have an exponent, and the exponent here is a variable. So we just have to log both sides of the equation for easy simplification. So let's take log to base 2. We can equally use log to base 10, but because we want to eliminate these two fast, and so we're taking log to base 2. So we're going to have here log 2 to the power of a base 2 is equal to the log of 3 times 5, then base 2. We apply a simple property of logarithm, which is called the power law. It says that when you have your log x to the power of y, say move the power back to give us y times log our x. So if we apply this law, then we're going to move this power back here. And here we have a multiplication law of logarithm. It says that when you have your log m, then times your n, then this is same thing as log your m plus your log your n. So we're going to make use of these two laws first. So doing that is going to give us our a times the log of 2 base 2, right? Then this is equal to the log of our 3 base 2, then plus the log of our 5 base 2. All right. Now, we're having same base law here. It says that when you have, let's put it on this other side, it says that when you have your log, your k base k, this is equal to 1, provided that your k is not equal to 0. So if k is not equal to 0, we can rewrite this expression. So this is going to give us 1. So this is going to give us our a times 1. Let's use multiplication sign here. A times 1, everything equal to our log 3 is 2, the plus log 5 is 2. It is easy. So therefore we're going to have our a is equal to log 3 base 2, then plus log 5 base 2. Now this is the value of a, but we can simplify this value then. How? We don't have this in our calculator. We have the natural base, which is base 10 or base e. And so we can convert to base 10 or to base e. And so how do we do that? We apply the change of base law of logarithm. It says that when you have your log, your x base y, and you want to change the base to base z, this is going to give us log x base z. Okay, this is our z. Then all over log y, the base z. This is what we call the change of base law. Okay, so applying that to this, we're going to have our a will now be equal to log, we change it to base 10, right? So this is going to give us our 3 base 10 all over log 2 base 10, then plus our log 5 base 10 all over log 2 base 10. Okay, now if you check this and this are common. And so since they are common, we can rewrite this to give us our a is equal to log 3 base 10 plus log 5 base 10 all over log 2 base 10. So this is another format of rewriting the answer which we got from our question here. All right. Now, but from here, we want to verify this first answer here. If it actually satisfies the original equation, this is the first answer we got. Okay. In other words, this is first format of expressing the answer, and this second one is the second format of expressing the answer. So we want to show if this answer actually satisfies this original equation. So let's take our check. So check. Now, wherever we see A, we want to put in the value we solve for in here. Now, look at the value. So we want to put the whole of this quantity into the place of A. So this now implies that our 2 or to the power of our log 3 base 2, then plus log 5 base 2, close bracket, everything equal to R15. Yeah, we want to rewrite this according to the law of indices, which says that when you have your expression of this kind, a to the power of m plus n, say this is same thing as your a to the power of m times a to the power of n. Okay, so how do we rewrite this in this format? It is simple. So we can rewrite our expression here as 2 to the power of log 3 base 2, then times our 2 to the power of log 5 base 2, everything equal to our 15. Good. Now, if you check out this expression we have in here, what does this implies? We are having 2 to the power of log 3 base 2. And so this and this will leave the system. And so this expression is the same thing as our 3 because these 2 and this log base 2 will leave. The times, yeah, we have 2 and we have log base 2 here. And so these 2 and these 2 log base 2 will also leave. So here we are left with our 5. So we have here 5. Everything equal to our 15. So if we multiply 3 and 5, this will give us 15 equal to 15. So this shows clearly that the answer we solved for actually satisfied the original equation. And what is the answer? We said it's either this format or this format. Okay, so this brings us to the end of today's class. If you learned something from this video, give it a thumbs up. And if you're new here, do not forget to subscribe. See you in our next class. Till then, keep winning.